Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound is 2,3-butadiene 1-ol derivative, specifically an alene CH3H, C is equal to C is equal to CH, C, CH3 to CH2O. The left carbon of the alene bears CH3 and H, the right carbon bears H and the group C, CH3 to CH2O, a neopentyl type alcohol substituent, a carbon bearing two methyls and a CH2O group. Moving on to the next step. Understand alene geometry and reactivity. With Br2, alenes react with Br2 via electrophilic addition. However, in this substrate, the pendant CH2O group on the CH3 unit can participate intramolecularly. The alene has the structure CH3H, C is equal to C is equal to CH, C, CH3 to CH2O. Moving on to the next step. When Br2 reacts with the alene, the bromonium ion forms at one of the double bonds. The hydroxyl group, CH2O, can act as an internal nucleophile and attack the bromonium intermediate, forming a cyclic ether, tetrahydropyran or dihydropyran ring. The oxygen attacks to close a six-membered ring, displacing bromide or opening the bromonium ion. And for the final step, determining which double bond reacts and ring formation, the alene C is equal to C is equal to C. Br2 adds across one of the double bonds, generating a vinyl bromide at the remaining double bond position. The oxygen of CH2O attacks the activated carbon, bromonium on the terminal alene carbon bearing CH3 and H, forming a six-membered ring, OCH2C, CH3, 2CH, is equal to C, Br, CH, CH3, O closure. This produces a dihydropyran ring with a double bond remaining, with Br on the vinylic allylic position. Identify the product structure as option B. Option B shows a six-membered oxygen-containing ring, dihydropyran, with a double bond in the ring, Br on one of the sp2 carbons, the carbon that also bears H on the carbon adjacent to O bearing gem-dimethyl, the CH3, 2 carbon and gem-dimethyl, CH3 on the quaternary carbon next to O. This matches the product of intramolecular trapping of a bromonium ion on the alene by the pendant alcohol oxygen, giving a 2H dihydropyran with Br at C3, vinylic position, and the gem-dimethyl group at C2 adjacent to oxygen. A is fully saturated, inconsistent with an alene losing only 1 degree of unsaturation to give a ring while retaining a double bond. C has Br on an sp3 carbon rather than vinylic position, inconsistent with the regiochemistry. D lacks the key substituents, no gem-dimethyl clearly placed, no H shown correctly. Therefore, the correct answer is B. Therefore, the correct answer is option B.